Have you ever wondered what the average color of the entire universe is? In this audio course, we will explore a remarkable experiment that sought to answer this very question by blending the light from all known galaxies to discover their collective hue. The findings are not what you might expect, offering profound insights into how stars are arranged across the cosmos and compelling us to reconsider the very nature of our perception. The way you perceive color is, in itself, an incredible process. As creatures who navigate the world primarily through sight, we depend on light to make sense of our environment. The light entering your eyes is a complex mixture of various wavelengths, with each one representing a distinct color, which means that every moment you are observing your surroundings, your retinas are processing a rich tapestry of interwoven light. What is truly remarkable is that the light you can actually see represents just a minuscule sliver of the vast electromagnetic spectrum. This full range extends from long radio waves, which bring music to your ears, all the way to high-energy gamma rays, which remain completely invisible to you. Of all these energies, only that narrow band of visible light is detectable by the human eye. So, why do certain colors seem more vibrant to you than others? It all comes down to the way light interacts with matter and how your eyes process that information. This principle extends to the grandest scale. When you look up at the stars, the light you see is carrying fundamental secrets about the universe's makeup. Every star shines with a distinct signature, determined by its heat and elemental composition, effectively acting as a unique brushstroke on the immense cosmic canvas. But what determines the apparent color of entire galaxies? The explanation is found in the fascinating reality of our expanding universe. While it might sound theoretical, this expansion is fundamental to grasping the color of the cosmos. As galaxies speed away from us, their light is stretched, shifting it toward the redder part of the spectrum in a process known as redshift. Consequently, when you observe these distant galaxies, you are not just seeing their light, but also peering back in time as the universe relentlessly grows. Looking even further into the past brings us to the Big Bang, the cataclysmic event that initiated our universe. This primordial burst of energy forged space and time, but it also left an afterglow that still pervades everything. The cosmic microwave background, also known as relic radiation. This ancient light provides a crucial baseline for understanding the universe's overall color, which begs the question of how it influences what you perceive in the present day. As we explore the cosmos more deeply, we must account for a mysterious substance that critically shapes your perception of color: dark matter. You cannot see it directly, yet its gravitational effects are unmistakable, bending the pathways of light as it journeys across the universe. It is truly extraordinary to consider how this invisible component can so powerfully alter the way you see the colors of distant stars and galaxies. The chemical makeup of stars themselves is another vital piece of this puzzle. Every star is a unique blend of elements, and the interplay between these components and light is what ultimately dictates its color. You can see this in action with hotter stars, which typically shine blue, whereas cooler stars give off a reddish glow. Therefore, when you look at a star, you are not merely appreciating its aesthetic appeal. You are observing a testament to the history of the very elements it is made of. Albert Einstein's theory of relativity introduces an additional layer of complexity to how you understand color. According to his work, the light emitted by an object can be perceived differently depending on its velocity relative to you. This reveals that color is not an absolute property, but a variable that shifts based on your own motion and context, a realization that challenges your fundamental sense of an objective reality. To make sense of all this, astronomers rely on an essential technique known as colorimetry. This is the scientific discipline of precisely measuring and analyzing the colors of objects in space. Through these methods, scientists can decipher the properties of stars and galaxies, gaining critical information about their composition and dynamic behavior. So, remember that every color you see in the night sky is part of a scientific investigation into the nature of the universe. We must also consider a factor much closer to home, Earth's atmosphere. This thin, protective layer around our planet significantly influences what you see by filtering and scattering incoming light, which can change the colors you perceive from the ground. This atmospheric distortion has a major effect on astronomical observations, meaning that when you gaze at the stars, your view is always colored, quite literally, by the air above you. Astronomical photography provides a way to capture the stunning beauty of the cosmos, but it is important to understand the process behind these images. The way a celestial photograph is taken and edited heavily influences its final color palette. In many cases, the vibrant colors you see are created using sophisticated techniques to visualize information that is normally invisible to your eyes, blending scientific data with artistic interpretation. Keep in mind that every breathtaking space image tells a story that is equal parts science and art. Of course, light and color tell a profound story right here on Earth as well. The planet's immense biological diversity and its varied environments directly shape how you perceive color in your daily life. Every shade, from the bright pigments of a flower to the subtle colors of the landscape, serves a specific purpose within the ecosystem. Therefore, as you contemplate the color of the universe, it is worth reflecting on how that grand cosmic palette is mirrored in the world around you. Ultimately, the science behind rainbows can serve as a fitting analogy for our entire exploration of cosmic color. Just as a prism separates white light into its constituent parts, astronomers analyze the light from distant stars and galaxies to understand their fundamental nature. This act of breaking down light reveals the hidden composition of the universe, showing us that even the most seemingly simple colors contain a wealth of complex information. Have you ever considered how a rainbow, born from the refraction and dispersion of light, serves as a powerful metaphor for the universe itself? This beautiful display illustrates the intricate nature of color, hinting that the cosmos, much like a rainbow, is filled with unexpected wonders and subtle complexities. When we delve into cosmology and the theories surrounding cosmic light, we find that our comprehension is a constantly unfolding process. The quest to define the universe's color is therefore not purely scientific. It's deeply rooted in philosophy and our innate curiosity, with cultural influences playing a significant role in shaping how you and I perceive the cosmos. Across history, humanity has woven myths and legends about the light filling the universe, stories that capture our profound awe of the unknown and our deep-seated need for understanding. Consequently, when you gaze at the night sky, you are not merely observing a palette of colors, but are looking into a vast ocean of accumulated mythology and meaning. Ultimately, the question of the universe's color is an invitation to explore and marvel, reflecting our own drive to comprehend the world. This brings us to a more fundamental mystery: the perception of color itself, a fascinating and sometimes perplexing process. Have you ever stopped to think about how a single beam of light can fracture into the incredibly rich and varied spectrum of colors you see every day? The solution to this puzzle is found in the physics of light and the way your eyes translate its different wavelengths. Humans are only able to perceive a narrow band of the electromagnetic spectrum, which we call visible light, and the entire mechanism hinges on how an object reflects specific wavelengths while absorbing all others. It's important to remember, however, that our experiences with color are not universal. The existence of color blindness, which stems from variations in the eye's light-sensitive cells, is a clear example of this diversity. This variance means that each of us possesses a unique internal color palette, rendering the perception of color an intensely personal and subjective experience. While light is essential for perceiving color, the surrounding context is just as critical. Consider a red apple, which might look more orange under the glow of a warm yellow lamp, but appears distinctly crimson in bright white light. This raises an interesting question. Do some colors only exist for you under certain lighting? The answer is unequivocally yes, as your brain constantly interprets visual data based on the available light. Beyond just shaping what you see, light and color also have a profound impact on how you feel. Different hues can trigger distinct emotional responses, from the serenity of blue to the vibrant energy of red, because our reactions are shaped by a complex interplay of cultural conditioning and biological programming. The quality of natural sunlight significantly alters your perception of the world as well. On a bright day, the sun provides a full spectrum of light, causing colors to appear rich and dynamic. In contrast, an overcast sky can make the same scene seem muted and less saturated, demonstrating just how much the nature of ambient light dictates the atmosphere of your day. Yet, your perception of color isn't solely determined by light and context. It is fundamentally tied to the chemistry within your own eyes. The cone cells in your retinas are responsible for color vision, and there are 3 distinct types, each tuned to a different wavelength of light. It is the combined signaling from these cones that permits your brain to construct and interpret the entire rainbow of colors you experience. At times, this perception can be remarkably deceptive, as proven by various optical illusions. You might recall the viral internet phenomenon of the dress, which some people saw as white and gold, while others insisted it was blue and black, reminding us that how you see color is ultimately as subjective as your unique outlook on life. The behavior of light itself is also responsible for some incredible natural wonders, as it can be refracted, reflected, and scattered. This is precisely the mechanism that creates a rainbow after a storm, when sunlight filtering through suspended water droplets is split into its constituent colors. Delving deeper into this topic also reveals the significance of culture, where different societies assign unique meanings to the same hues. This diversity shows that colors function as more than simple visual stimuli. They form a complex visual language that communicates deep meaning and emotion. In the end, understanding how you perceive color is a journey that travels through physics, biology, and culture. It encourages you to contemplate the way you view your surroundings and recognize how your own personal experiences transform something as seemingly common as color into something truly remarkable. Ultimately, the way you interpret color not only shapes your individual identity, but also links you to the immense and varied tapestry of the human condition. Realizing how you perceive color enhances your appreciation for the beauty all around you and encourages a continuous exploration of the universe's secrets. Are you aware that the colors you see represent merely a tiny fraction of the immense spectrum of light? When you discuss color, you are referencing an incredible sensory phenomenon that is intrinsically tied to the light in your environment. Light itself is essentially a tireless wanderer, coursing through space to deliver information about the world. But how do you actually process this light and convert it into the experience of color? The portion of the electromagnetic spectrum that is visible to you extends from violet to red, constituting just a small sliver of the whole. Have you ever paused to consider how your eyes manage to discern such a vast array of hues? Your eyes possess specialized cells, known as cones, which are tasked with detecting light and relaying those signals to your brain. Think of every cone as a miniature artist, diligently painting a scene from the light it captures. Each of the three types of cones is tuned to a different wavelength of light, which means that the color you perceive is determined by the specific wavelength that stimulates them. Light, however, doesn't always behave in a uniform way. It can be absorbed, reflected, or transmitted. Every one of these interactions directly influences how you perceive colors in your surroundings. For instance, an object you perceive as blue isn't blue in and of itself. What's actually happening is that it soaks up nearly all wavelengths of light, except for the blue wavelength, which it bounces back toward your eyes. Can you even begin to picture a world devoid of these intricate exchanges between light and matter? It would be a reality without any color, a place where every single thing existed in shades of gray. The electromagnetic spectrum reaches far beyond the limits of your vision, encompassing invisible wavelengths like ultraviolet and infrared rays. If you had the ability to see within these frequencies, the universe would unfold before you in ways you've never imagined. Would you be curious to live a day as someone who could perceive these hidden colors? Such a person might see thermal energy instead of visible light, or perhaps even the faint trails left by insects on the ground. To grasp how these unseen wavelengths relate to the colors you know, consider a rainbow. As sunlight filters through a raindrop, the light separates into a full spectrum of colors, resulting in the magnificent display you are familiar with. This process, which scientists call dispersion, serves as a flawless illustration of how light can be transformed to reveal its fundamental composition. Isn't it remarkable that a simple ray of light contains a whole rainbow of brilliant colors? Furthermore, the light you perceive doesn't just originate from manufactured sources like light bulbs or digital screens. The universe is constantly sending light your way. Every single star you see in the night sky radiates light that carries detailed information about its unique composition and its surface temperature. Starlight, then, is a direct communication from the cosmos, with each star acting as a distinct beacon on an enormous cosmic canvas. But how can you possibly determine the color of a distant star? Astronomers employ a technique called spectroscopy to analyze the light a star emits. By breaking that light down into its constituent spectrum, they can identify its specific colors and, from there, deduce its chemical makeup. This form of analysis is vital not only for studying individual stars, but also for decoding the story of the universe as told through its light. Different wavelengths of light narrate different tales about the origins and the ongoing evolution of the cosmos. Have you ever wondered what the entire universe actually looks like? While your eyes are incapable of seeing it all, science has devised methods to interpret the cosmos through the light that manages to reach you. In this exploration of light and color, it's critical to acknowledge the role that light plays in the creation of images. Astronomical cameras are truly amazing instruments, designed to gather the faint light from faraway objects and transform it into images that you can understand. During the capture of these images, however, scientists often use processing techniques that can modify the representation of colors. So, is it plausible that what you see in a photograph of space isn't an exact depiction of reality? The answer is a definite yes, as light can be manipulated to highlight certain details, enabling an exploration of the universe in ways your unaided eyes never could. The way you perceive color is also heavily influenced by its context. For example, the same color can look quite different depending on the other colors that border it. This effect is referred to as simultaneous contrast. The deeper your understanding of color perception becomes, the more apparent it is that your visual experience is, in part, an illusion, one beautifully crafted by light and the context in which it appears. Light is more than just a physical phenomenon. It also shapes your emotional experiences. Colors have the power to elicit specific feelings and prompt reactions, from the comforting warmth associated with yellow to the sense of peace brought by blue. Color is therefore not merely a subject for science, but also a medium for art and personal expression. On its relentless journey, light provides a visual spectacle that goes far beyond simple observation, inviting you to contemplate your own position in the cosmos. Finally, you should remember that the study of light and color is a constantly advancing field. As your collective understanding of the universe deepens, you also discover new methods for seeing and engaging with light. Each new scientific breakthrough moves you closer to solving the cosmos's greatest puzzles, and serves as a reminder that even though you are a tiny part of this immense expanse, your capacity to perceive color is a thread that connects you to this incredible journey. What further secrets about color and light is the universe waiting to show you? Only time and unending human curiosity will provide the answers. Every star is a celestial furnace, a sphere of incandescent gas where nuclear reactions generate immense energy, and with it, light. Have you ever stopped to think about how this light can reveal the very makeup of each star? When you look toward the heavens and see a star, you are not simply viewing a point of light, but are actually observing a piece of its history. The light that finally reaches your eyes has journeyed for thousands, millions, or perhaps even billions of years, like a timeless messenger completing an epic voyage to reach you. The specific color of the light a star emits is determined by its temperature. Blazing hot stars, which can achieve temperatures of 10,000 degrees, radiate a brilliant blue light, whereas cooler stars that barely surpass 3,000 degrees give off a warm reddish glow. It's truly fascinating to realize that the different colors we see scattered across the night sky are direct reflections of the temperatures of these enormous, fiery spheres. But how can we precisely identify the elements present within a star based only on the light it sends us? This is accomplished through a powerful technique called spectroscopy. By passing a star's light through a prism, we can split it into a full spectrum of colors, much like a rainbow. Within this spectrum, each chemical element leaves behind a unique signature, as if every star possesses its own individual calling card. A dark line observed in a star's spectrum, for example, can signify the presence of an element like hydrogen or helium, turning each star into an open book that tells us about its composition and its past. You can conceptualize starlight as a kind of universal language. Each color we perceive is like a word that informs us about the physical conditions deep inside that star, providing clues about its age, mass, and even its ultimate fate. In this respect, stars are like the great sages of the universe, imparting their profound wisdom through the light they continuously emit across the cosmos. But what occurs when these stars are at different points in their lifespans? And how does their color evolve as they age? Stars progress through a number of distinct phases during their existence, beginning their lives as young, hot, and brilliantly blue celestial bodies. Over time, they can expand to become red giants, and some will eventually detonate in massive explosions known as supernovae, leaving behind breathtakingly colorful nebulae. Every single stage of a star's life is distinctly marked by these transformations in its color. So, the next time you find yourself gazing at the stars, remember that each color represents a different chapter in its life, a constant reminder that everything in the universe is in perpetual motion. The light from stars doesn't just inform us about the stars themselves. It also helps us understand the vast universe that envelops us. By carefully studying starlight, astronomers are able to map the chemical composition of our galaxy and of others far beyond it. Can you imagine having the ability to peer beyond our own world and comprehend how everything around us came to be? Each star is one piece of an enormous cosmic puzzle, and its light is what allows us to connect all the dots. It's also important to note that not all stars are created equal. Some are significantly brighter than others, and this luminosity also influences the color that we perceive from our vantage point. The most brilliant stars may appear white or blue, while their dimmer counterparts often look reddish, a variation in brightness and color that speaks to the incredible diversity of the universe. Each star is a unique entity, complete with its own personal history and legacy. As we explore the study of starlight more deeply, it's vital to remember that our understanding depends not only on what we can see, but also on what remains invisible to us. Visible light constitutes only a tiny fraction of the entire electromagnetic spectrum. Stars also radiate light at other wavelengths that our eyes cannot detect, such as X-rays or radio waves. This implies that there is a great deal more to the universe than we can ever capture with our sight alone. So how do we go about uncovering these hidden colors? The solution is found in our technology. By using telescopes and satellites that are specifically equipped to detect this wide range of wavelengths, scientists can analyze the universe in completely new ways. These sophisticated tools enable us to capture the light from extremely distant stars and investigate their composition, their movement, and their evolution over time. Every single discovery brings us one step closer to solving the fundamental questions about the light that fills our universe. Furthermore, the light from stars plays a critical role in the creation of new celestial bodies. When a star dies and explodes, it scatters its constituent elements across the vastness of space, which can then be recycled to form new stars, planets, and perhaps even life. It is a continuous grand cycle of creation and destruction, and every color that we are able to observe is intimately connected to this cosmic process. It's an astounding realization that the hues we see in the night sky are an integral part of such a magnificent cycle. Ultimately, it is essential to keep in mind that every time we gaze upon the starry sky, we are engaging with the universe on a very profound level. The light of the stars prompts us to reflect on our own existence and our place within the cosmos. The next time you look up and spot a twinkle in the darkness, remember that you are observing messages sent from the distant past, a beautiful and complex reminder of the universe's majesty. It is a journey of light and color that unites us all, one that will continue for as long as we keep exploring the mysteries of the cosmos. So, how is the ongoing expansion of the universe linked to the colors we see in the sky? To comprehend this connection, it's necessary to explore the phenomenon of redshift, a concept that might sound complex but has explanations that are both fascinating and easy to grasp. When a star or a galaxy is moving away from us, the light it emits is stretched. This stretching of light is very similar to what occurs when a fast-moving car produces a lower-pitched sound as it drives away from you. This effect is known as redshift, and it serves as one of the primary keys that helps us understand how the universe is changing and expanding. Now, what exactly does redshift signify for the colors of the universe? Imagine that the spectrum of visible light is a full palette of colors, where each hue has a very specific wavelength. When a galaxy is receding from our position, the wavelength of its light gets longer and shifts toward the red end of the spectrum. This not only changes what we are able to see, but also provides us with vital clues about what is happening throughout the cosmos. In other words, the colors we observe in the sky are not merely a visual spectacle. They are a direct message about the dynamics of the universe itself. In the early 20th century, the astronomer Edwin Hubble unveiled a truly staggering fact. The velocity at which a galaxy recedes from us is directly proportional to its distance. This was a groundbreaking realization, as it dismantled the idea of a static cosmos and revealed a universe in perpetual motion. Evidence for this expansion is found in the light from distant galaxies, which is stretched toward the red end of the spectrum, meaning that every time you gaze into the night sky, you are witnessing the universe in the very act of evolving. This discovery has profound implications for how we comprehend the cosmos, beginning with our ability to determine its age. By carefully measuring the current rate of cosmic expansion, scientists can effectively rewind the clock to calculate the time elapsed since the Big Bang. You can picture the universe as a continuously inflating balloon. The points on its surface grow farther apart as it gets bigger. Similarly, by gauging the speed of this separation, we can deduce how long the universe has been expanding since its moment of creation. Furthermore, redshift serves as a critical tool for understanding the universe's material makeup. Through the analysis of galactic light, astronomers can identify the specific elements that are present across vast cosmic distances. A significant shift toward red in a galaxy's light might suggest a composition rich in heavier elements, whereas a more subtle shift can point to a prevalence of lighter ones. In this way, every hue you observe in the cosmos offers a vital clue to the unique history and composition of these distant star systems. This cosmic phenomenon is not, however, confined to the most remote galaxies. It also shapes your perception of celestial objects much closer to home. Even the light from our own sun, for example, undergoes a slight redshift as it travels through space. This means that the very sunlight reaching your eyes is subtly altered by the universe's ongoing expansion. Consequently, when you look up, you are observing not just stars and planets, but the pervasive influence of the cosmos on your own immediate experience. Ultimately, a grasp of redshift is essential because it opens a window onto the entire history of the universe. When you notice the varied colors and tones in the sky, you can recognize that they narrate a grander story of colliding galaxies, the birth of new stars, and the violent upheavals that have sculpted our cosmos. It serves as a powerful reminder that while the universe may appear tranquil from our earthly perspective, it is a place of constant motion and transformation. As our exploration of the cosmos continues, the reality of redshift also prompts compelling questions about what lies ahead. If this expansion persists indefinitely, what will the universe look like billions of years from now? Is it possible we could arrive at a future where galaxies are so distant that their light can no longer reach us at all? These thoughts compel us to reflect on the very nature of space and time, and on how our perception of the universe itself is destined to change. In the end, the principle of redshift is more than just a captivating astrophysical concept. It is an invitation for you to contemplate your own connection to the universe. Each color you see in the heavens is a reminder that you are part of something immeasurably vast, a cosmos that is always expanding and changing. So, the next time you find yourself looking at the stars, remember that every flicker of light is an echo of the universe's story, and a testament to the colors that shape our existence. The Big Bang, an event that took place roughly 13.8 billion years ago, did not just initiate space and time. It left a permanent signature on the color of the universe. This primordial imprint is known as the cosmic microwave background radiation, which you can think of as the enduring echo of the Big Bang that still permeates all of space. Much like the ripples that spread from a stone tossed into a pond, waves of incredibly hot energy from that initial moment have expanded and cooled over eons, transforming into the faint, pervasive glow we can detect today. While we cannot perceive the cosmic microwave background radiation with our own eyes, as it exists in the microwave part of the spectrum, Scientists have measured its temperature at approximately 2.7 degrees Kelvin. This temperature, though exceedingly cold by our standards, is proof of a universe that was once unfathomably hot and dense. By studying this remnant radiation, astronomers have learned that the nascent universe was saturated with light and energy, which has since stretched and faded into the faint afterglow we observe now. From the standpoint of human perception, it's vital to remember that color is not merely a wavelength of light, but an interpretation created by our minds. The light you see is shaped by many variables, including the temperature and composition of the objects emitting it. The cosmic microwave background, also known as relic radiation, functions as a kind of universal backdrop, providing context for the starlight and galactic light we see today. You might imagine yourself in an art gallery, where each painting possesses its own distinct tones, but all are viewed against the foundational color of the gallery walls, subtly influencing your perception of the entire collection. Consider the cosmic microwave background radiation to be the ambient illumination within that grand gallery. In its absence, the hues of the artworks would lack their richness and significance. In much the same way, the light originating from stars and galaxies is influenced by this ancient radiation, which serves as a key tool for us to better comprehend the makeup of our universe. But what further insights does the cosmic microwave background radiation offer regarding the color of the cosmos? By examining its patterns and fluctuations, scientists have successfully uncovered a wealth of knowledge about the universe's large-scale architecture. This includes confirming the presence of dark matter, a theoretical substance that neither emits nor interacts with light, and mapping its distribution across the cosmos, essentially making this radiation an ancient chart for navigating the vastness of space. The persistent question, then, is what the true color of the universe is. The answer is far from straightforward. While the cosmic microwave background provides vital clues, the color of the universe is in a state of perpetual flux. As new celestial bodies are born and others die out, the spectrum of colors we can observe is constantly transformed, meaning the universe is not one single shade, but a kaleidoscope reflecting its dynamic evolution. As we explore this subject more deeply, you must realize how the Big Bang shaped not only the light we observe, but also our very interpretation of it. The entire history of the cosmos is inscribed in the colors of the stars, and each point of light you see in the night sky is an echo from that primordial past. The investigation into the cosmic microwave background and its relationship to the universe's color is an ongoing scientific endeavor. Modern observatories and satellites are instrumental in peeling back the layers of mystery surrounding this radiation, providing us with an increasingly sharp image of how the universe was formed and has evolved. Every fresh discovery poses new questions, compelling us to look beyond the surface and find more profound links between color and the history of everything. The cosmic microwave background is therefore not merely a relic of the Big Bang. It is a direct portal to the universe's core essence. This ancient light serves as a reminder that, even though we cannot perceive the universe's light in its entirety, its energy envelops us, molding our view of the cosmos and its boundless beauty. So, the next time you gaze up at the stars, I want you to contemplate the deep history of light and color that each one carries, a legacy with roots reaching back to the very dawn of time. Have you ever stopped to think about how dark matter contributes to the color of the universe? Picture the cosmos as a colossal canvas of intertwined colors, where every thread is a galaxy, star, or planet. Yet, behind this spectacular display, an invisible mass exists that fundamentally alters how you and I perceive everything else. We may be unable to see dark matter, but it is indispensable for understanding the universe in its totality, including its coloration.
Dark matter is estimated to constitute roughly 85% of all matter in the universe. So how can an invisible substance possibly impact the light and color that we are able to see? To grasp this, you first need to understand how light behaves as it interacts with matter. When light from a distant star travels near a massive object, such as a galaxy filled with dark matter, its trajectory is bent. This effect, known as gravitational lensing, is a primary method astronomers use to investigate dark matter. It is through this bending process that light can actually have its color altered, and this is where dark matter assumes a critical role. When we analyze light that has journeyed through different densities of dark matter, we can identify shifts in its spectrum. These subtle changes give us information about where dark matter is concentrated throughout the universe. It is as if dark matter itself is painting the cosmic canvas, subtly modifying how we perceive the colors of distant stars and galaxies. But what makes dark matter so fundamental to the universe's color? The answer is found in its profound influence on the creation and development of cosmic structures. Without the gravitational pull of dark matter, galaxies would not have been able to form in the way they have. All the visible matter we see, like stars and gas, is drawn toward this unseen substance, which fosters an environment where galaxies can flourish and, consequently, radiate light. In this way, the colors you observe across the universe are directly contingent on the existence of dark matter. Think of dark matter as the very skeleton of a masterpiece. Lacking a robust frame, the artwork itself could not hold its intended form. In the same vein, dark matter supplies the essential gravitational scaffolding that allows visible matter to gather and shine across the immense emptiness of space. If you were to witness galaxies in a cosmos devoid of dark matter, you would be met with an entirely different reality, one where the lights and colors would appear far less brilliant and varied. However, the interplay between dark matter and light does not stop there. It also has a significant effect on how we register the colors of celestial bodies. As you look into the night sky, every star and galaxy radiates light across different wavelengths, which produces a rich assortment of colors. The presence of dark matter, however, can stretch or compress these wavelengths, causing some stars to seem bluer or redder than they truly are, a phenomenon referred to as the gravitational Doppler shift. Furthermore, dark matter can affect the way light scatters on its journey to us. When starlight traverses a dense cluster of dark matter, it can be dispersed in a manner that causes the colors we observe on Earth to misrepresent reality. It's akin to viewing the world through a piece of colored glass. What you perceive is inherently distorted by the medium you are looking through. This implies that your perception of the universe's color is, in part, a grand optical illusion. Just imagine the thrill of being able to touch dark matter and witness firsthand how it manipulates the colors all around us. While we may never be able to do that, scientists are continually creating more sophisticated techniques to analyze its effects. Through the use of powerful telescopes and other advanced instruments, they are steadily unraveling the enigmas of this invisible material that permeates our existence. Every new breakthrough brings us closer to a fuller picture of the universe's color. The hunt for dark matter is not simply a compelling scientific quest. It represents a profound journey toward comprehending our own place in the cosmos. By exploring how this invisible substance alters light and color, we confront deeper questions about reality and our role within it. Dark matter is not only essential to the universe's structure, but it also serves as a stark reminder that the visible world is just a sliver of the total reality. The twinkle of every star and the faint glow of distant galaxies are all shaped by this unseen force, which acts as a primary architect in the grand cosmic design.
So, the next time you gaze at the night sky, remember that there is far more present than what your eyes can perceive. The colors you see are the product of a celestial ballet between light and dark matter, and each glimmer is an invitation to explore a universe brimming with complexity and wonder. Have you ever questioned why one star shines with a brilliant hue while another appears more muted? The solution to this puzzle originates deep inside the stars, where chemistry functions as the universe's true artist. You can envision each star as a living palette, where its specific chemical elements act as the pigments that generate the light we see. This entire process is influenced by how elements like hydrogen and helium shape the colors you are able to perceive. Imagine for a moment that every star is a chef in its own cosmic kitchen, orchestrating a series of nuclear reactions with a unique blend of ingredients. Hydrogen, the most common element, serves as the primary fuel for most stars. But when that hydrogen is depleted and the star starts cooking with other materials, helium and heavier elements enter the scene. As stars progress through their lives, their changing colors signal their transition into new evolutionary stages. So why is color so critical in the field of astronomy? The answer is that a star's specific shade provides invaluable data regarding its temperature, its makeup, and its age. For instance, blue stars are exceptionally hot, while red stars are comparatively cool. This direct relationship between color and temperature is one of the foundational keys to deciphering the complete life cycle of stars. Astronomers utilize a method called spectroscopy to dissect the light that stars emit. By separating this light into its constituent colors, much like a prism forms a rainbow, they can determine the precise elements contained within the star. You can think of it as a scientific superpower that lets you deduce a celestial body's composition just by studying its color. Each dark line that appears in a star's spectrum corresponds to a chemical element that has absorbed light, thereby revealing the star's innermost secrets. The chemistry of stars also allows us to trace the origins of the elements throughout the universe. In the earliest moments of cosmic history, only the simplest elements, such as hydrogen and helium, existed. As stars lived out their lives and perished, they forged heavier elements inside their cores, in a process that resembles a great cosmic factory. When a massive star explodes in a supernova, it scatters these new elements across space, enriching the interstellar medium with the building blocks of planets and life itself. If you have ever contemplated why Earth is composed of such a wide variety of elements, the explanation is found in the history of stars. A star's internal chemistry not only dictates its color but also governs the composition of everything around us. Consequently, every time you look up at the star-filled sky, you are actually observing the ancient history of the very matter that constitutes our universe. Speaking of color, it is important to know that some stars radiate light in wavelengths that are invisible to the human eye. The hottest stars, for example, shine intensely in ultraviolet light, while certain cooler stars might emit more of their light in the infrared spectrum. This implies that if our eyes could see these wavelengths, the night sky would appear completely different. Furthermore, this stellar chemistry also directs how these elements combine into new molecules, turning stars into cosmic laboratories that can eventually form planets, and perhaps even life. The current phase of a star's life is vividly expressed through its color. Young stars, which are rich in hydrogen, typically exhibit a bright blue hue, whereas older stars that have used up most of their fuel shift toward yellow or red. This progression through the color spectrum illustrates the story of stellar evolution. A star's transformation is much like a human life cycle. It develops, it changes, and it eventually fades, leaving behind a legacy of matter for the generations to come. Ultimately, while the light from stars is mesmerizing, it also makes us ask questions about the future of the universe. What will take place when stars continue to burn their fuel and finally disappear? The answer resides with the next generation of stars, which will form from the remnants of their predecessors. In this way, the cycle of stellar chemistry goes on, and the color of the universe is in a constant state of transformation. When you look up at the night sky, remember that every color tells a story that has been unfolding over billions of years.
You might think of color as a simple matter of visual perception, but its significance extends far deeper. Across the vast expanse of the universe, where stars punctuate the darkness, a remarkable phenomenon links color directly to Albert Einstein's theory of relativity. It's natural to wonder how this groundbreaking theory, which reshaped our comprehension of space and time, could possibly influence something as fundamental as the colors you see. To understand this connection, you first need to recall that color is our brain's interpretation of the light that enters our eyes. This light, however, can act in very surprising ways, particularly when an object is traveling at velocities approaching the speed of light. As an object hurtles toward you, the light waves it emits become compressed, causing a perceptual shift toward the blue part of the spectrum, in an effect known as blue shift. In contrast, when an object is moving away, these light waves stretch out, and you perceive a corresponding redshift. Let's bring this concept down to earth with a more familiar scenario. Picture yourself at a racetrack, watching a high-performance car speeding around the track. As it races towards your position, you might notice its color seems to intensify and brighten, which is a direct analogy for blue shift. Then, as the car passes and recedes into the distance, its color appears to fade and become duller, illustrating the same principle behind redshift that we observe in space. Relativity's influence isn't limited to objects moving at extreme speeds. It also governs the force of gravity. The light emitted from an incredibly massive object, like a star or a black hole, is profoundly affected by its powerful gravitational field. This means that as you observe light traveling through such a strong field, you can witness a distinct change in its color, with gravity itself causing the light to appear redder or bluer based on the specific circumstances. This brings us to a compelling question. Can relativity truly alter the way you perceive the color of a star? The answer is an emphatic yes. When you look at a star, the light traveling from it can be bent and distorted by the gravity of other massive bodies that lie between it and you. This gravitational interference can cause the star's light to shift, making it seem redder or bluer depending on its cosmic location and the intricate dance of motion between our planet and the star. Let's explore a specific effect called gravitational redshift. This phenomenon occurs when light has to escape from an intense gravitational field, such as the one produced by a star or black hole. As the light battles its way out of this gravitational pull, it loses energy, and its waves stretch, shifting its color toward the red end of the spectrum. In this way, relativity not only explains how objects journey through the cosmos, but also how their movement and presence directly impact the very light you perceive. But is it actually possible for us to witness these relativistic effects from here on Earth? Yes, it is, though these changes are far too subtle for you to notice with the naked eye. Astronomers employ powerful telescopes and specialized instruments to meticulously analyze the light spectrum from distant stars and galaxies. Through this spectral analysis, they can identify the faint shifts in color that reveal whether a celestial object is moving toward or away from us. This capability raises an even more profound question. What is the ultimate role of color in our quest to understand the universe? Astronomers have essentially learned to decipher the cosmos's book of colors. Every star, planet, and galaxy possesses a distinct color signature, a kind of fingerprint that discloses critical details about its chemical composition, surface temperature, and motion. Consequently,
When you study this light, you are doing more than appreciating its beauty. You are actively decoding the secrets of the universe itself. Furthermore, the unique chemical elements that constitute a star play a significant role in determining its color. For instance, a star that is predominantly composed of hydrogen will radiate a different shade of light compared to a star made mostly of helium. This diversity in light emission provides a window into the history and evolutionary path of stars over cosmic timescales. So, when you gaze up at the night sky, you are not merely seeing points of light. You are witnessing the life story of each star, narrated through the colors it broadcasts across space. The interconnected effects of relativity and color serve as a powerful reminder of just how intricate and complex our universe is. The fundamental forces of light, motion, and gravity are woven together in ways that are often invisible to us, yet they produce profound consequences for our perception of reality. So, the next time you find yourself looking at a brilliant star, remember that its hue is the product of a grand cosmic dance between immense speeds and unseen forces. Ultimately, Einstein's theory of relativity provides a new lens through which to view the universe, enriching our understanding of not just space and time, but light itself. Every glimmer of starlight you see is a testament to a cosmos in perpetual motion, brimming with wonders and surprises. This might lead you to ask how scientists can possibly determine the properties of light from celestial objects that are millions of light years away. Astronomical colorimetry is an incredible discipline that allows us to unravel cosmic mysteries by analyzing the colors of stars, galaxies, and planets. But what exactly is this field, and how does it function across the unfathomable distances of space? Think of it like being at a massive concert, where every vibrant light has a specific purpose and evokes a particular feeling. In much the same way, each color you observe in the heavens tells a unique story about the nature and condition of celestial bodies. To grasp the basics, consider the way a rainbow forms after a storm. The reason you see that spectrum of colors is because sunlight is being split into its constituent wavelengths, with each wavelength corresponding to a different color. Astronomers apply this same principle. When they observe a distant object, they don't just see a bright dot. They capture its light and break it down, analyzing the spectrum of colors to extract a wealth of invaluable scientific information. How is this analysis carried out? The colossal telescopes that gaze into the cosmos are fitted with specialized tools known as spectrographs. You can think of a spectrograph as an advanced prism that separates incoming light into its constituent colors. This instrument provides astronomers with an object's light spectrum, which in turn exposes details about its chemical makeup, temperature, and motion. Every star possesses a distinct spectrum, much like a unique fingerprint, allowing scientists to identify the elements it contains by comparing its light signature to the known spectra of those elements. But do the colors you perceive remain consistent across the entire universe? The answer is a definitive no, as light from far-off objects can be altered by several factors, including redshift. This phenomenon, which is a direct consequence of the universe's expansion, occurs when a celestial body is moving away from us. As astronomers observe a remote galaxy, they can see its colors shift, a realization that profoundly impacts our cosmic understanding. Furthermore, an object's temperature heavily influences its color. Hotter stars radiate with bluish tones, whereas cooler stars give off a reddish glow, enabling astronomers to deduce a star's evolutionary stage simply by analyzing its hue. Beyond stars, the science of colorimetry extends to investigating planets and their atmospheres. For instance, by examining the light from an exoplanet, scientists can analyze its spectrum to find out if it possesses clouds, oceans, or even potential indicators of life. In this context, color serves as a vital clue to the conditions on another world, advancing the search for habitable planets. Color analysis is also central to studying the cosmic microwave background, which is the residual light from the Big Bang itself. This ancient radiation has been stretched to the red end of the spectrum, offering us unparalleled insights into the primordial universe and its large-scale structure.
Now, what about the light that has to travel through Earth's atmosphere? This atmospheric layer often distorts the light we receive, a variable that astronomers must constantly correct for in their observations. It's for this very reason that many major telescopes are situated in high, arid locations, far from the interference of city lights and atmospheric pollution, all in the quest to capture the most pristine light possible. You can visualize Earth's atmosphere as an immense lens that bends and alters the light arriving from space, posing a significant challenge to our perception of the cosmos. But have you ever considered precisely how this atmospheric interference shapes the colors we observe in the sky and in celestial objects? Our atmosphere doesn't just filter light, it also distorts it, producing a spectacle that is simultaneously beautiful and misleading. When you look at the daytime sky, the blue that envelops you is not a direct property of sunlight, but the result of a process called Rayleigh scattering, where sunlight collides with air molecules. This same phenomenon explains why at dawn and dusk the sky can blaze with orange and red tones, as the sunlight must pass through a thicker slice of the atmosphere, scattering away the shorter blue wavelengths and allowing the warmer colors to reach your eyes. This atmospheric effect isn't limited to our sky. It also impacts our view of celestial bodies like stars and planets. As we peer through telescopes, the light from these distant objects is warped by the atmosphere, which can compromise the precision of our findings. Think of it like trying to see through a fogged-up window. The view is blurred and unclear. This atmospheric distortion presents a persistent challenge for astronomers, as shifting conditions like humidity, temperature, and pressure change how light behaves on its journey to us. Consequently, understanding these effects is critical, because if astronomers cannot secure an accurate reading of a star's colors, they risk losing vital information about its composition and its distance from us. To overcome these obstacles, specialized techniques have been created to compensate for the atmosphere's influence on astronomical observations. One of the most effective strategies involves placing telescopes above the atmosphere entirely, with the Hubble Space Telescope being a prime example. Moreover, the technology for capturing and processing cosmic images has progressed dramatically. The advanced cameras on modern telescopes can detect a spectrum of colors invisible to the human eye, enabling astronomers to produce breathtaking visuals that are as rich in scientific data as they are beautiful. Ultimately, the study of colors in astronomy extends far beyond mere aesthetics. Each subtle nuance and every shade carries profound meaning, helping scientists decode answers to fundamental questions about our existence. What are our origins? How did the universe begin? And what awaits us beyond the limits of our vision? In this way, colorimetry serves as an indispensable tool for comprehending the cosmos, connecting the dots between the light we observe and the truths we can infer. So, in the end, every star that glimmers in the night sky is a reminder that a vast universe of mysteries, of which we can only see the very tip of the iceberg, is waiting to be discovered. By orbiting high above our planet, the Hubble telescope sidesteps the blurring effects of the atmosphere, enabling it to record celestial objects with far greater color accuracy and clarity. This unobstructed vantage point allows scientists to analyze starlight in its most pristine state, which in turn deepens our overall comprehension of the universe. Here on the ground,
astronomers pursue a similar goal by situating observatories in high-altitude, arid locations where the air is significantly thinner and more stable. This strategic placement allows them to greatly diminish atmospheric interference and collect more reliable data on the colors of cosmic bodies, much like finding the perfect seat for a light show where fewer obstacles lead to a superior view. Yet, our atmosphere is not the sole variable that influences how we perceive cosmic colors, as light pollution, particularly from urban centers, presents a major challenge. The overwhelming glow of city lights can easily overpower the faint light from the stars, effectively erasing many of their subtle hues in the process. You can just picture the immense frustration of an astronomer whose attempts to capture the universe's splendor are constantly thwarted by this artificial glare, a persistent issue for both professionals and amateurs alike. Furthermore, the Earth's atmosphere is in a constant state of flux, with events like volcanic eruptions or massive forest fires injecting particles into the air that can additionally warp our perception of color. Consequently, a brilliantly blue sky one day might appear with a brown or gray tint the next due to airborne pollutants, a frequent reminder of just how dynamic our environment is and how it shapes our view of the cosmos. So, you might wonder what can be done to sharpen our perception of the universe's palette. A growing number of people are coming to understand the critical importance of darkness and the need to preserve the natural night sky. By actively working to reduce light pollution, we not only improve the quality of stargazing, but also safeguard vital nocturnal ecosystems, making it a collective endeavor well worth our effort. Ultimately, whenever you gaze up at the night sky to watch the stars, it's worth remembering that you're witnessing not merely distant points of light, but also the distinct influence of our own planet's atmosphere. Every individual color and each twinkle contributes to a grand narrative about the universe and our unique perspective on its immense scale. Think of astronomical photography as a portal to a remote and captivating reality, where color serves as an essential tool for understanding the cosmos. But how exactly are those breathtaking images you see in publications and online actually produced? The method involves a sophisticated fusion of science, cutting-edge technology, and a measure of visual artistry. And on this journey, I'll unveil the secrets to capturing the universe's colors and the crucial data they contain. To start, it is remarkable to consider that a cosmic photograph is not a simple snapshot of reality, but an intricate interpretation of light that has journeyed for millennia to reach us. Every celestial body, whether a star, galaxy, or nebula, radiates energy at various wavelengths that our instruments translate into an array of different colors. Now, let me ask you an interesting question. What if I were to tell you that a great many of the colors you observe in these pictures are not what your own eyes would register? The specialized cameras employed for cosmic imaging are vastly different from the ones we use daily. These instruments are engineered to perceive wavelengths of light far beyond human vision, which encompasses only a tiny fraction of the electromagnetic spectrum that also includes X-rays, ultraviolet, and infrared radiation, leading to what we call false color images. But what exactly does that term signify? Picture yourself in a completely dark room with a projector capable of displaying the full light spectrum. Using only white light produces a basic image, but adding filters to accentuate specific wavelengths will utterly transform it. This is precisely how astronomical imaging works, as astronomers use filters to isolate distinct wavelengths of light, generating pictures that highlight particular characteristics of cosmic objects. For instance, a photograph of a nebula might be processed to display hydrogen as red, oxygen as blue, and sulfur as green, offering us immediate visual cues about its chemical makeup and physical form. The final image, however, is shaped by more than just the selection of filters. The technique known as photometry is absolutely essential to this entire process, as it allows us to perform a quantitative measurement of the light coming from celestial bodies and thereby analyze their fundamental properties. If you've ever tried to gauge the brightness of a flashlight in a dark space, you have a basic idea of photometry, though on a vastly more intricate scale. By measuring light intensity across different wavelengths, scientists can ascertain not only the color, but also the temperature and chemical composition of stars and galaxies. Another captivating element of astronomical photography is the application of image integration. Imagine you are attempting to make out a whisper during a loud concert. A single attempt would likely fail. But if you were to record the sound repeatedly and layer the recordings, the faint details would start to become clear. In a similar fashion, astronomers capture multiple exposures of a single cosmic object, and then combine them to forge a much sharper and more detailed final image, a method that reveals colors and tones that would otherwise be lost in the background noise of space. In the realm of astrophotography, time itself is a crucial element, as some images demand very long exposures, while others can be taken in mere seconds. Can you fathom the immense duration required to gather the faint light from a galaxy situated millions of light years from Earth? It is common for astronomers to spend many hours, or sometimes even several days, focused on the same object, patiently waiting for enough light to collect, to create a lucid image that unveils the hidden colors of that faraway world. However, the creative process does not conclude at that point. The use of digital processing is a fundamentally important step in the craft of astronomical photography. After the light data from space is collected, scientists employ sophisticated software to meticulously fine-tune its brightness, contrast, and colors. This process is far more than simple photo editing. It is a careful scientific procedure grounded in a profound understanding of light and color physics. Have you ever considered how an image changes when its colors are calibrated to what researchers theorize they should be? Such processing can fundamentally reshape your perception of a celestial body. Moreover, you may find that images from different observatories have their own distinct visual style when it comes to color. A telescope that operates in the infrared spectrum, for instance, will produce an image with colors that look completely different from one taken by a standard optical telescope. This variation arises because each instrument is engineered to detect specific light wavelengths, thereby uncovering different characteristics of the cosmic objects under investigation. Colors in space can also serve as chronicles of the universe's past. Certain images capture the radiant aftermath of immense cosmic calamities, like supernova explosions, which unleash staggering amounts of energy and light across the entire spectrum. Consequently, the brilliant and deeply saturated hues you see might be the lingering evidence of events that transpired millions of years in the past, giving us a way to gaze back through time and comprehend the origins of our universe. In the realm of learning, astronomical photography serves a crucial purpose. These vibrant and awe-inspiring images have a unique ability to spark the curiosity of both the scientific community and the wider public. More than just being beautiful, these pictures are powerful educational instruments that clarify complex astrophysical principles. By examining the colors of a spiral galaxy or the intricate form of a nebula, students can develop a much deeper connection to the subjects they are exploring. Ultimately, it's essential to recognize that while our technology has made incredible leaps, enabling you to witness the cosmos in its full chromatic glory, the real magic is found in the allure of what remains unknown. Every new photograph prompts us to pose more questions and venture beyond the limits of our vision. What other colors fill the universe? And what astounding secrets will the next generation of telescopes bring to light? The quest for knowledge persists, with each captured image representing just one small fragment of an immense cosmic puzzle.
Color stands out as one of the most compelling features of our planet. But have you ever stopped to think about the part color plays in the biodiversity of Earth? Nature displays an extraordinary gift for crafting a brilliant visual spectacle, from the vivid feathers of birds to the rich spectrum of shades and flowers. Why does such a multitude of colors exist, and what is their effect on the existence of living things? Let's delve into this fascinating question.
To start, color in the natural world is about much more than just appearance. In many instances, it is an indispensable instrument for survival. The striking colors of certain frogs, for example, act as a clear warning to would-be predators. Should a predator spot a brightly colored frog, it may associate those shades with something inedible, showcasing an amazing way that evolution has transformed color into a language of caution.
Beyond just providing defense, color holds a central role in attraction. The intense hues of flowers are specifically evolved to draw in pollinators. But did you know that insects perceive the world in a very different way than you do? While humans see a limited range of colors, many insects possess ultraviolet vision, which allows them to discern patterns on flowers that are entirely invisible to our eyes, making color a vital communication link between plants and the creatures that pollinate them. The sun's light is the fundamental source of all color on our world, yet not all colors are expressed identically. The way light is absorbed and reflected determines the particular shades that you perceive. For instance, tree leaves appear green because their chlorophyll absorbs red and blue light, but reflects the green part of the spectrum. Have you ever observed how a slight shift in lighting, such as at sunset when the landscape is bathed in golden and red tones, can completely transform a scene? Now, let's consider the ways in which the environment shapes coloration.
In certain landscapes like deserts, you'll find that colors are typically warmer and more earth-toned, whereas in the oceans, shades of blue and green are dominant. This is not a coincidence, as factors like climate, soil makeup, and the presence of water all guide the coloring of the organisms that reside in these areas. Color, therefore, becomes a mirror of the environment, a direct adaptation to the unique conditions of a given place.
Biology, too, has a significant influence on color. Melanin, a pigment present in a vast number of organisms, dictates the color of skin, fur, and feathers. Through this lens, you can see how natural selection has prioritized specific colors in different species. Animals that possess more adaptive coloration are more likely to survive and reproduce, revealing the intricate and balanced system nature has perfected over millennia.
The interplay between living things and their surroundings encourages us to think about the deep interconnectedness of all life on Earth. Colors are not only critical for an individual's survival, but also shape the wider dynamics of entire ecosystems. Predators, their prey, and the pollinators that support plant life all rely on color cues to navigate their existence. As a result, a modification in the color of a single species can send ripples throughout the whole ecological web. Humanity, however, has also left its mark on the planet's biodiversity and its array of colors. Practices like intensive farming, along with pollution and climate change, are disrupting natural ecosystems and altering the colors you might have once taken for granted. For example, some butterfly species are losing their brilliant hues due to the destruction of their habitats. This forces us to confront a critical question. What will become of biodiversity if we fail to act to safeguard our environment?
Colors also exert a profound emotional influence on us.
The blue of the sky can foster a feeling of tranquility, whereas the color red might trigger excitement or even feelings of unease. This link between color and human emotion has been recognized and utilized by numerous cultures across history. It makes you wonder how the colors of nature truly shape your perception of the world and contribute to your overall sense of well-being, acting as a silent language that communicates directly with your emotions. In the scientific community, biologists are delving into the ways color shapes the behavior of animals. For instance, certain studies reveal that fish with more vibrant hues are more successful in attracting mates. This prompts the question of what other revelations the study of color in the natural world might hold for us. Each new insight brings you closer to grasping the intricate tapestry of life itself, offering an endless wellspring of inspiration for any keen observer of nature.
Even a simple walk through a forest where you can witness the diverse palette of leaves and flowers, or a glance at the sky, can deepen your appreciation for the world's beauty. When was the last time you truly paused to take in the colors of your immediate environment? Ultimately, the spectrum of biodiversity serves as a vivid reminder that life on our planet is a wonderfully complex and varied phenomenon, with each color telling its own story and serving a unique function within the ecosystem. Contemplating this allows you to see beyond mere visual appeal, recognizing the profound interconnectedness of every living thing on this planet. The next time you witness a rainbow arching across the sky or a landscape bursting with dynamic color, I encourage you to take a moment and consider the hidden narratives they contain. Each hue is a testament to life, adaptation, and the sheer magic that permeates our world. Have you ever looked at a rainbow and found yourself wondering about the mechanics behind such a breathtaking spectacle? The splendor of colors that unfurls in the sky following a storm is undeniably one of nature's most awe-inspiring sights. Yet, behind this display lies an intricate dance between light and atmosphere, which is responsible for producing these vibrant spectra. Together, we will now explore the science that explains rainbows, which will not only clarify this phenomenon, but also deepen your understanding of color throughout the universe. To grasp how a rainbow is formed, you must first understand the nature of light. What you perceive as white light, such as the light from the sun, is actually composed of a full spectrum of colors, from red all the way to violet. When this light passes through a medium like a simple drop of water, something fascinating happens. Each individual droplet functions like a tiny prism, causing the incoming light to slow down and bend in a process we call refraction, which separates the white light into its constituent colors. As the light moves to exit the water droplet, it also reflects off the interior surface, almost as if it's playing a game within the water. When it finally emerges, it does so at an altered angle, which arranges the colors into the specific sequence you see in the sky, with red appearing at the top and violet at the bottom. This precise ordering occurs because each color bends at a slightly different angle during refraction, resulting in the familiar pattern we all recognize. This naturally leads to the question of whether all rainbows look the same, and the answer is that they do not. The intensity and clarity of a rainbow can differ significantly based on atmospheric conditions, such as the amount of available sunlight and the size of the water droplets. For instance, a particularly brilliant rainbow might manifest after a gentle rain, when the droplets are small and uniform, allowing them to scatter the light more evenly and produce a more vivid effect. But what happens when you see two rainbows at once? On rare occasions, an even more stunning event, known as a double rainbow, can be observed. This occurs when light reflects not once, but twice inside the water droplets. This secondary reflection creates a fainter,
secondary arc above the primary one, in which the order of the colors is completely reversed. It's a remarkable display that reveals another layer of nature's complexity and beauty. Many people wonder if it's possible to actually catch a rainbow. While you can never physically reach one, you can certainly capture its fleeting beauty in a photograph with the right angle and camera exposure. In fact, astronomical photography employs similar principles to record the magnificent colors of the cosmos, though that is a topic for another time. There are also unusual variations, like white rainbows or moonbows, which are generated by the light of the moon on clear nights when a full moon illuminates falling rain. The scientific principles behind rainbows do more than just explain their formation. They teach you about the fundamental properties of light and color. Every color you perceive is the product of an interaction between light and matter. This concept encourages you to consider how the light from stars and other celestial objects behaves in a similar fashion, allowing us to witness the universe in its full, colorful magnificence. So the next time you find yourself admiring a rainbow, I hope you'll remember that it is more than just a beautiful visual event. It stands as a powerful illustration of the interplay between light and matter in our world, acting as an invitation to explore the science of color on a cosmic scale. This all leads to a grander question. What color is the universe? Perhaps the answer is that it is a composite of everything, a vast cosmic rainbow, still waiting for you to discover it. Cosmology, the captivating scientific field dedicated to studying the origin and evolution of the universe, is also central to our comprehension of cosmic color. These cosmological theories are essential tools that help you decode the light that reaches us from across the cosmos. To truly understand this, it is vital to recognize that color is not merely a visual quality, but a profound record of how the universe was born and has expanded over billions of years. When you gaze at the night sky, your eyes meet the light of thousands of stars, each with varying brightness. Behind every single twinkle lies a deep history connected to the light and energy that star emits. Cosmological models tell us that the universe originated with the Big Bang, an event that not only set time and space into motion, but also produced the mixture of chemical elements from which the stars would later form. Thus, the color of a star directly reflects its temperature and composition, and this is precisely where cosmology provides the answers. For a moment, picture the universe as a vast blank canvas, where every star represents a single brushstroke of pigment. Stars that burn with greater intensity, like blue ones, give off light with shorter wavelengths, whereas their cooler, red counterparts release light at longer wavelengths. Consequently, a star's hue provides us with valuable information about its surface temperature and where it currently is in its life cycle. It's truly remarkable to consider that a simple color can unlock the hidden history of a distant star, don't you think? As we explore cosmology, it becomes clear that the universe is in a state of continuous expansion. This process does more than just increase the distances between galaxies. It fundamentally alters the way we perceive their light. The light emitted by galaxies moving away from us is stretched toward the red end of the spectrum, a phenomenon we call redshift. This shift in color is far more than a mere visual quirk. It serves as a portal into the universe's past, offering clues that help us decipher its expansion and evolution. What, then, does this redshift suggest about the ultimate fate of our cosmos? Cosmologists have developed a number of theories to account for the universe's origins and essential characteristics. The theory of inflation, for instance, proposes that the universe underwent a period of exponential growth in the initial fractions of a second following the Big Bang. This incredibly rapid expansion not only ensured an even distribution of matter, but also shaped the very way light travels and how we observe it. Inflation is therefore not merely a captivating idea. It is a critical factor influencing the celestial colors you see.
The cosmic microwave background, often described as the lingering echo of the Big Bang, stands as another vital element of cosmology, linked to the color of the universe. This faint radiation permeates the entire cosmos and can be detected in every direction you look. By studying this remnant light, which exists mostly in the infrared spectrum, scientists are able to learn more about the makeup of the early universe and its history, gaining insight into its condition moments after its birth. How does this ancient radiation ultimately shape our perception of cosmic color? When you delve deeper into cosmology, it's apparent that dark matter, that unseen substance we cannot directly observe, also plays a role in defining the universe's color. While it doesn't engage with light in the same manner as ordinary matter, its gravitational pull dictates the formation of galaxies and the large-scale structure of the cosmos. The hidden influence of dark matter leads us to question how our comprehension of color might transform if we could finally unravel the secrets of this enigmatic material. Furthermore, Einstein's theory of relativity, which completely changed our view of space and time, carries its own implications for how we perceive color. The light we observe can actually change in environments with extreme gravity, or when objects travel near the speed of light. This effect, known as gravitational redshift, serves as a powerful reminder that color is a subjective experience, capable of shifting based on the conditions of the observer. Isn't it fascinating that the universe operates by its own set of rules that directly affect what you see? Breakthroughs in telescope technology have also empowered astronomers to investigate the cosmos in ways that were once purely theoretical. With the most advanced generation of instruments, we can now analyze the colors of celestial objects with incredible precision. These endeavors are not only broadening our knowledge of the universe, but are also giving us a rich palette of colors that helps us piece together its evolutionary story and composition. What other cosmic truths might we uncover as our exploration continues? Within this framework, cosmology provides a perspective that transcends the simple observation of color. It beckons us to contemplate our place within this immense cosmos, and to recognize how every color you perceive is a fragment of its long history. Each star, each galaxy, and every single shimmer of light contributes to a grand cosmic narrative that is still being written. What is the significance of this for us as human beings? The link between cosmology and color is, in the end, a testament to a universe teeming with mystery and wonder. As we investigate this relationship, we are likely to find not only solutions to our questions about cosmic light, but also entirely new questions that will drive our quest for knowledge forward. It is human curiosity that fuels our desire to gaze at the stars and persist in uncovering the secrets of the cosmos. So, on your next clear night, when you look up at the sky and contemplate the true color of the universe, just remember that every hue, every twinkle, and every shadow tells a piece of that story. Cosmology is the lens that allows us to see not only the colors of the universe, but also our profound connection to it. What other shades and secrets does the endless cosmos have in store for us in the years to come? The pursuit of understanding is a journey without end, where each new discovery marks the beginning of another great adventure. Color wields an incredible, captivating influence. Its significance goes far beyond aesthetics, being deeply woven into our emotions, our cultures, and the way we make sense of the universe. Have you ever stopped to consider how the colors in your environment actively shape your life? Every shade tells its own story, from the deep blue of the sky to the vibrant red of a sunset. Across history, different cultures have assigned powerful meanings to various colors. Red, for example, can evoke feelings of passion or signal danger, while blue often brings to mind a sense of peace and tranquility. But what makes these associations so widespread? The answer might be found in the fundamental ways we experience the world around us. Light is more than a physical phenomenon. It carries a symbolic weight of cultural and emotional meaning that shifts from one society to another. For instance, in many African cultures, the color black symbolizes wealth and fertility, whereas in some Asian societies it can be linked with mourning. Have you ever considered how profoundly color can alter your perception of reality? In certain cultures, yellow is a sign of happiness, while in others, it serves as a warning. This remarkable diversity in interpretation highlights the complex and vital role that light plays in all of our lives, even extending to its importance in our rituals and celebrations. In Mexico, the Day of the Dead bursts forth as a vibrant celebration, using a brilliant palette to pay tribute to beloved relatives who have passed away. Every shade has a specific purpose. Orange channels the sun and the essence of life, whereas purple communicates a deep sense of mourning. More than mere decoration for the occasion, these colors actively narrate tales about the profound bond between the living and the departed. Beyond cultural festivities, color has a demonstrable impact on our feelings within various settings. Scientific studies have confirmed that environments adorned with warm tones, including reds and oranges, can significantly heighten one's energy and imaginative drive. In contrast, cool colors like blues and greens generally encourage a state of relaxation and sharpened concentration. Isn't it fascinating to consider how a seemingly minor detail like color can sway your mood and overall effectiveness? The cultural weight of color is also powerfully felt in the realms of fashion and art. Within the fashion industry, particular colors can define an era's trends, capturing the prevailing spirit of the time. Black, for instance, has solidified its status as a hallmark of elegance and refinement, while pink has transitioned from a shade tied to childhood into a potent emblem for the movement toward gender equality. Have you ever considered how color choices can mirror our collective social and cultural preoccupations? In the art world, color has long served as an essential instrument for expressing complex emotions and abstract ideas. You can see this in the paintings of Vincent van Gogh, where his radiant yellows stir sensations of happiness and dynamism, or in the works of Pablo Picasso, whose blue periods convey an atmosphere of sadness and contemplation. Every artist manipulates light and hue in a unique way to communicate their personal worldview. Which specific colors manage to stir particular emotions in you when you encounter them in a piece of art? This deep connection between color and culture is likewise apparent in our gastronomic traditions. Across numerous societies, the colors present in food can directly alter our perception of its flavor profile, with brightly hued dishes often being perceived as more enticing and delicious. Have you ever found yourself more excited to taste a meal simply because its presentation was exceptionally colorful? Spirituality and symbolism are also intrinsically linked with specific colors. Within Christianity, the color white is a representation of purity and divine redemption, while in the Hindu faith, orange is revered as a sacred color that signifies spiritual enlightenment. This persistent association suggests that throughout human history, people have looked to the visual world to find deeper meaning and a sense of connection. How do you suppose color might shape the beliefs and spiritual customs of different societies? The cultural significance of color even shapes our interpretation of the cosmos itself. The vast spectrum of cosmic hues, from the brilliant flashes of distant nebulae to the subtle tones of neighboring planets, has fueled myths and legends across countless civilizations.
Ancient Mesopotamian societies, for example, viewed the night sky as an immense tapestry whose colors represented their gods and the epic stories surrounding them. How do you believe the colors of space have shaped our conceptions of the divine?
Simultaneously, the colors of the universe can act as a unifying force that brings diverse cultures together through the lens of science. The shared pursuit of space exploration and the detailed study of celestial objects have enabled scientists from all over the globe to collaborate on new discoveries and theories. As our collective knowledge about the light from the cosmos expands, we also unite in a common effort to comprehend our position within it. How might this shared understanding influence our cultural view of the universe? As we continue to deepen our comprehension of the cosmos, our interpretation of color is certain to evolve alongside it. Groundbreaking technologies and new scientific insights will undoubtedly reveal novel ways of perceiving and making sense of the universe. What new layers of meaning do you imagine will emerge as our understanding of color in space progresses?
Ultimately, color is far more than a simple matter of individual perception. It serves as a powerful thread that weaves all of humanity together. From our earliest ancestors to the modern day, color has been a primary vehicle for communicating emotions, preserving traditions, and expressing core beliefs. By reflecting on how color shapes our lives and societies, we can better appreciate the intricate mosaic of meaning that connects us all. What part do you foresee color playing in the next chapter of cosmic exploration and human understanding?
Throughout history, the colors of the universe have consistently ignited our curiosity and sense of wonder, extending far beyond a purely scientific interest. From ancient Greece to contemporary societies, color has carried profound importance, symbolizing everything from the creation of the world to the very nature of divinity. How is it that a domain as immense as the universe possesses a color palette capable of inspiring such enduring myths and legends? This exploration delves into some of the beliefs and narratives that have journeyed with us through time, uncovering the link between the cosmos and human culture. Our earliest civilizations gazed upon the night sky and perceived not just stars, but a realm of deities and supernatural powers. In Greek mythology, for instance, the sky was Zeus's domain, and he was frequently illustrated in a blue cloak to mirror the image of the celestial sphere. What resonance does this particular shade of blue hold in our modern-day perception of the cosmos? Ancient peoples used color as a method to interpret what they could not otherwise comprehend, which led to the creation of myths that gave their existence profound meaning. Consequently, each color grew into a symbol for the stories that connected humanity to the divine. In Chinese culture, the color blue also possessed a unique and powerful significance, where it was associated with the concept of immortality and seen as a representation of harmony and equilibrium throughout the universe. The notion that a single color can encapsulate such a wealth of meaning is a powerful idea that echoes across many traditions. As you explore different cultures, you find that a color like red can signify good fortune in one part of the world, while in another, it might be tied to warfare or sacrifice. With such diversity, what color could possibly represent the universe as a whole? Ancient civilizations also sought to explain the marvels of the cosmos by weaving intricate stories and myths. For the Mayan people, the Milky Way was envisioned as a celestial river of stars, a sacred path that the gods used to travel between our world and the afterlife. This interpretation reveals not only their deep admiration for the universe, but also how the colors of the stars and the glow of the night sky profoundly shaped their rituals and belief systems. Every star that glimmered in the night sky served as a link between humanity and the divine.
In the mythology of numerous northern cultures, the heavens are portrayed as an immense blue canvas where the gods would paint the shimmering lights of the aurora borealis. This spectacular natural event, with its cascading curtains of light, was often interpreted as a divine omen or a direct message from the heavens. It makes you wonder how a simple interplay of light and atmosphere could inspire such powerful legends that have survived through the ages, revealing nature itself as a vibrant storyteller.
If you explore African traditions, you discover that the color black holds a profound significance, symbolizing fertility, creation, and life itself. Many cultures across Africa view the cosmos as a perpetual cycle of renewal, where black represents the rich, fertile soil from which all living things spring. The striking contrast between black and other colors, like the brilliant gold of the sun, illustrates a complex cosmology that deeply connects people to their land and the universe. Within the traditions of North America's indigenous peoples, the star-dusted night sky is regarded as a celestial mirror of the terrestrial world, with each constellation narrating the history of their ancestors. In this worldview, the starlight acts as a guide, helping individuals navigate not only the physical landscape, but also their own heritage. This profound link between the heavens and culture serves as a powerful reminder that the colors of the universe are not merely light, but are foundational stories that sculpt the identity of a people. The impact of myths and legends on our perception of the universe's colors isn't confined to ancient history. Even today, many of us continue to search for and find meaning in the hues we observe in the sky. The notion that color can influence our emotional state is now widely acknowledged, with color psychology playing a significant role in modern art, marketing, and our daily lives. Could it be that when you gaze at the sky, you are subconsciously seeking answers to the same fundamental questions that have captivated humanity for centuries? Our scientific understanding has grown, providing us with deeper knowledge of the universe's composition. Yet the ancient myths continue to resonate within our modern search for meaning. The cosmos's grand narrative is still being written through the colors we perceive, and every new scientific breakthrough adds another page to this timeless book of legends. This shows that the color of the universe is a concept woven not just from physics and chemistry, but also from our deepest emotions, hopes, and dreams. Looking ahead, the convergence of science and mythology promises to be a continuously fascinating realm of inquiry. The quest for exoplanets and the detailed analysis of starlight will likely unveil not only new truths about the cosmos, but also fresh insights into how colors perpetually fuel the stories of our culture. You have to ask, what new myths will be born as our comprehension of the universe continues to expand? Ultimately, the color of the cosmos is a reflection of our own collective experiences and beliefs. Put it simply, the myths and legends surrounding the color of the universe stand as a powerful testament to human curiosity and our intrinsic bond with the cosmos. From the era of ancient Greece to our own time, light has acted as a great unifier, bridging gaps between diverse cultures and successive generations. When you look up at the sky, you are witnessing more than just stars and galaxies. You are seeing a reflection of our own humanity, a reminder that in this vast universe we are always searching for meaning in the colors that paint our world.
Now, what if I were to tell you that an exoplanet's color can reveal stories about its atmosphere and its potential to harbor life? Across the immense expanse of space, countless worlds orbit distant stars. Although you cannot see them with your own eyes, science has developed brilliant techniques to investigate their colors. So, how exactly are these observations made, and why does color hold such critical importance?
First, let's consider the nature of color itself. When you observe any object, what you are seeing is the light it reflects, and this very principle extends to planets far beyond our solar system. Astronomers employ incredibly powerful telescopes and advanced instruments to dissect the light bouncing off these celestial bodies. By analyzing this light, they can determine not just the planet's hue, but also the makeup of its atmosphere and the potential conditions on its surface. Isn't it extraordinary that a subtle variation in color can unveil so much information? For instance, an exoplanet that reflects a greater amount of blue light might possess vast liquid water oceans, whereas a world glowing with a reddish tint could be a barren landscape covered in rock. This type of color-based classification is crucial for scientists who are on the hunt for habitable worlds. The challenge, however, is how they succeed in capturing this faint, distant light against the backdrop of space. The solution is found in what are known as spectroscopic techniques. This technology functions by deconstructing light into its constituent parts, similar to how a prism splits white light into a rainbow. Through the careful analysis of an exoplanet's light spectrum, astronomers can identify the different elements present in its atmosphere. In fact, did you know that detecting certain gases, like oxygen or methane, could be a strong indicator of potential life? I want you to imagine yourself in a laboratory, examining the light that has traveled from a distant exoplanet. Every single line that appears in the spectrum you're studying can signify a unique chemical element, making the process akin to deciphering a musical score. Each distinct note provides a clue about what exists on that faraway planet, revealing that the music of the universe is incredibly rich, with every exoplanet contributing its own unique melody. Of course, the process is far from straightforward, as the immense distances to these worlds present a formidable challenge. The light from a parent star is frequently so overpowering that it completely washes out the dim reflection from an orbiting planet. To overcome this, scientists have engineered sophisticated methods to filter out the star's intense glare, allowing them to isolate the exoplanet's light. It's much like trying to hear a friend's whisper at a loud concert. You have to find a way to silence the background noise to catch their voice. Furthermore, it's important to remember that exoplanets are incredibly diverse. Some are massive gas giants, much like Jupiter in our own solar system, while others are small, rocky worlds similar to Earth. Each of these distinct planetary types reflects light in its own unique way, adding another layer of complexity and wonder to their study. Consider that gas giants possess turbulent atmospheres that can scatter light in very particular ways, meaning a single color can carry different implications based on the kind of planet you're examining. For worlds that are extremely distant, astronomers can't always view them directly. Instead, they analyze the light that filters through the planet's atmosphere as it passes in front of its star. This process, called a transit, gives starlight a path through the planet's atmosphere, uncovering vital details about its makeup and features. You can think of it like peering through a dusty window pane. The image isn't perfect, but you can still make out what lies on the other side. Yet, the analysis of an exoplanet's color goes beyond the search for life, offering clues about the climate and geology of these remote worlds. A world that absorbs light in a peculiar way might signal the presence of extreme weather, or even environments that are inhospitable to life. Such data helps scientists grasp not only the planet in isolation, but also its place within the larger stellar system. As our technology progresses, so do the techniques for detecting and interpreting the colors of exoplanets, with space telescopes like the James Webb Space Telescope being engineered precisely for these kinds of investigations. Because these instruments can perceive wavelengths of light invisible to your eyes, they are unlocking new pathways to discovering worlds that were once completely out of reach. In a way, the hunt for exoplanets is like playing a massive cosmic detective game, where each new finding about a planet sparks bigger questions and fresh lines of inquiry. Color acts as a critical clue in this grand puzzle, lighting the way toward answers about our own existence.
It is truly astounding to realize that an exoplanet's color does more than just help us understand these far-off places. It actually broadens our comprehension of the entire universe. Every new discovery beyond our solar system encourages you to contemplate your own life and our collective place in this immense cosmos. So when you next find yourself looking at the stars, consider that each point of light could be shining on a world of vibrant colors waiting to be found.
This fascinating pursuit of exoplanets and their colors takes you to the very frontiers of the universe, where stars act as beacons in the dark and new worlds are waiting. But why are we so captivated by the light coming from these planets? Just as a detective scrutinizes every clue to solve a mystery, scientists depend on light as a crucial instrument in their cosmic investigations.
After an astronomer confirms an exoplanet's existence, one of the initial inquiries is always about its material composition, and the answer is often concealed within the light it either reflects or radiates. Every chemical element has its own distinct color signature, which acts like a unique fingerprint that allows you to tell it apart from all others.
Through the analysis of light arriving from an exoplanet, scientists can unravel the atmospheric makeup of that world, seeking out elements like oxygen, hydrogen, and methane. It's incredible to think that color alone can expose the chemistry of a planet that is thousands of light years distant. This method of studying planetary colors is known as spectroscopy. If you can picture a prism fracturing white light into a full spectrum of colors, you can understand how spectroscopy functions. It separates the light from an exoplanet into its various wavelengths. This process lets scientists see the precise colors that signal which gases are present. Just think of the countless stories these colors could tell you about the atmosphere of a faraway world. The hunt for exoplanets extends beyond just observing the color of light that arrives here. Advanced telescopes are also employed to spot variations in a star's light as a planet crosses its path. This event, the transit, leads to a minor reduction in the star's brightness. By analyzing this subtle dimming, you can gather crucial information about the planet's size and composition. There is a complication, however. A great number of exoplanets are incredibly remote and frequently veiled by dense clouds that can mask their genuine color. This means the hue you observe may not belong to the planet itself, but is instead an artifact of its atmosphere. For instance, a world might look blue because of water vapor, when in fact it is a barren, rocky landscape. To surmount these difficulties, scientists are pioneering novel technologies. Imagine an instrument that can perceive not just visible light, but also other wavelengths, like infrared or ultraviolet radiation. Using such tools, astronomers can construct a far more comprehensive view of the conditions on these remote worlds, placing you on the verge of a new era in space exploration. In addition, artificial intelligence is starting to take on a pivotal role in the analysis of astronomical data, as its algorithms can process vast amounts of information with greater speed and accuracy than people can. This allows us to find new exoplanets and study their colors with much higher efficiency. Can you picture a future in which a computer could pinpoint a new planet just by examining its light signature? Global teamwork is also forging new pathways forward, with observatories worldwide collaborating to share data and insights. This collective effort fosters a deeper understanding of exoplanet color and composition, since every team contributes unique expertise and technology. The quest for exoplanets is also fundamentally connected to the search for life, as the presence of certain colors in a planet's atmosphere, such as the combination of oxygen and methane,
can point to the possibility of biological processes at work.
Is it possible that we are witnessing a cosmos where life flourishes based solely on its coloration?
With the advent of space missions like the James Webb Space Telescope, our capacity to analyze the hues of distant exoplanets is dramatically improving. This powerful observatory allows us to perceive wavelengths that were previously hidden from view, granting us an unprecedented look into the atmospheric makeup of other worlds.
The future of astronomical study appears incredibly vibrant, promising a spectrum of new discoveries and colors. As our exploration of the cosmos deepens, it inevitably leads to a reflection upon our own place in it all. Every shade and tint we identify in the universe serves as a powerful reminder of the intricate complexity and diversity of life right here on Earth. In essence, by examining these other worlds, we embark on a journey to understand not just the universe, but also ourselves.
Doesn't the thought that every star and planet might hold a narrative waiting to be uncovered fill you with wonder?
The investigation into the colors of exoplanets ultimately makes us contemplate the profound connection shared by all things across the cosmos, with each new finding drawing us nearer to grasping the sheer scale of our surroundings. This quest for distant worlds and their palettes is, in many ways, a search for humanity's own origin story, written among the stars.
So, the next time you gaze up at the night sky, I want you to remember that every single color and every subtle twinkle is an open invitation to explore, to dream, and to discover. This grand adventure is only just beginning, and every one of us has the opportunity to be a part of it. What incredible marvels might be waiting for us within the infinite, unexplored expanses of the universe?
The enigma of the universe's color has been with our species throughout its history. From the very first moment a human being looked up at the star-filled heavens. But have you ever stopped to consider what the light of the cosmos truly represents? Is this just a matter of visual appeal, or does a more significant truth lie behind this captivating mystery? By exploring this question together, we'll see that the color of the universe is far more than an astronomical curiosity. It's a gateway to comprehending the fundamental fabric of reality itself.
When you observe the stars, you're witnessing much more than simple points of shimmering light.
Every glimmer conveys a story about the composition, temperature, and remoteness of these celestial objects. On a clear, star-dusted night, you'll notice a variety of hues, with some stars shining with a distinct bluish light, and others appearing more reddish. While this might seem like a mere visual quirk, each color is actually a critical clue that helps astronomers piece together how a celestial body is born and how it changes over time.
The light that finally reaches your eyes is a composite of countless wavelengths, and each one corresponds to a particular color. However, the journey of this light through space and time is affected by the relentless expansion of the universe, which plays a pivotal role in what we see. As galaxies recede from us, the light they radiate is stretched toward the red end of the spectrum. This phenomenon not only allows us to observe the cosmos in motion, but also empowers us to decipher its long and complex history, turning light into a messenger from the distant past.
One of the most profound clues to the universe's color is the cosmic microwave background radiation, often described as the lingering echo of the Big Bang. This faint radiation, which permeates all of space, provides a snapshot of the primordial universe as it existed before the first stars and galaxies ever formed. Yet, this raises the question: are the colors we perceive a true reflection of the universe's energy? Or are they an illusion constructed by our own senses? Even dark matter, which constitutes the majority of the universe's mass and is invisible to us, subtly alters our perception of cosmic color by influencing the light that travels through it. The chemical elements that constitute stars function much like ingredients in a grand cosmic recipe, with each element emitting and absorbing light in a unique way, thereby giving stars their signature colors. Hydrogen, for instance, tends to glow with blue and violet light, whereas different elements can cause a star to appear more yellow or red. It's an incredible concept that when you observe a remote star, you are seeing not just its brilliance, but the entire chronicle of its existence. Albert Einstein's theory of relativity introduces yet another layer of intricacy to our perception of color. A phenomenon known as the Doppler effect dictates that as objects travel at immense velocities, the color we perceive can shift. This means two separate observers, one moving and one stationary, could view the very same object and register its color differently, which is an amazing testament to how relative something as fundamental as color can be. Modern advancements in colorimetry, the science dedicated to studying and measuring color, enable us to analyze the wavelengths of light from celestial bodies with remarkable precision. This technology not only helps us pinpoint the specific elements present in a star, but also reveals crucial details about its temperature and age. It's as if our telescopes can both see and listen to the stories the universe tells through its light. Our own planet's atmosphere also significantly shapes how we perceive the colors of the cosmos, as it filters and scatters light, altering the hues that reach our eyes. You can see this effect during a sunset, when the sky is painted with brilliant oranges and reds because of the angle at which sunlight passes through the air. Astronomical photography has fundamentally transformed our view of the cosmos, as the images we capture are far more than simple pictures. They are visual representations of complex data, often processed to accentuate colors that would be completely invisible to the human eye. In this way, each astronomical image becomes a unique piece of art where color represents not just light, but the very composition and history of the celestial objects themselves. And here on Earth, color tells its own compelling story, with the incredible biological diversity of our world being inextricably tied to its vibrant palette, from the deep green of the forests to the shimmering blue of the oceans. This intrinsic link between color and life reveals that our quest to discover the universe's color is fundamentally connected to our own existence. Rainbows offer another brilliant reminder of the beauty of color and its relationship with light. When sunlight passes through water droplets and refracts, it unfurls into a full spectrum, a phenomenon that is not only visually captivating, but also perfectly illustrates how light and color are woven together in our world. As we venture deeper into the field of cosmology, we are confronted with ideas that challenge our very perception of the universe's color. Various interpretations of the cosmos, ranging from the established Big Bang model to the speculative multiverse theory, compel us to question whether color is an inherent quality of the universe, or simply an illusion shaped by our senses. Light also possesses profound cultural significance. Throughout the course of history, civilizations across the globe have ascribed unique meanings and symbolism to light, reflecting their distinct understandings of the cosmos. This makes you wonder what these interpretations say about our connection to the universe and the very nature of our interaction with it. Furthermore, the ongoing search for exoplanets encourages us to consider light in contexts that stretch far beyond our solar system. By analyzing the light signatures from these distant worlds, our efforts are not just aimed at finding new forms of life, but also at confronting the immense possibilities for color diversity throughout the cosmos. In the end, the question of the universe's color invites an exploration that goes beyond the science of light and perception, touching upon our personal connection to everything around us. From the distant stars to the vivid tones of our own planet, every shade serves as a reminder of the complexity and beauty of being. So, What color is the universe? It's possible there isn't one definitive answer. But what we do know is that every color tells a story. And with each story, we come a little closer to understanding our place in it all.